The history of quantum mechanics stretches back to the late 19th and early 20th centuries, when scientists started to discover phenomena that couldn't be explained by classical physics. Quantum mechanics is the branch of physics that deals with the behavior of matter and energy at the atomic and subatomic scale, where the rules of classical physics break down. One of the key early figures in the development of quantum mechanics was Max Planck, who introduced the concept of quantization in 1900. Planck was trying to explain the spectrum of blackbody radiation, which is the electromagnetic radiation emitted by a body at a given temperature. He proposed that the energy of the radiation is not continuous, as had been previously thought, but rather is emitted and absorbed in discrete packets or quanta. This idea was later called the quantum hypothesis, and it laid the foundation for the development of quantum mechanics. Another important figure in the early history of quantum mechanics was Albert Einstein, who made significant contributions to the theory with his theories of special and general relativity. Einstein's theory of special relativity, which was published in 1905, introduced the concept of spacetime and the equivalence of energy and mass. In 1911, Einstein applied the idea of quantization to the photoelectric effect, which is the emission of electrons from a metal surface when it is illuminated by light. He proposed that light is made up of discrete packets of energy, called photons, and that the energy of the photons determines the kinetic energy of the emitted electrons. This theory was confirmed experimentally, and Einstein was awarded the Nobel Prize in Physics in 1921 for his contributions. One of the major breakthroughs in the development of quantum mechanics came in 1924, when Louis de Broglie proposed the concept of wave-particle duality. De Broglie suggested that, just as light can exhibit both wave-like and particle-like properties, all matter, including particles such as electrons, can also exhibit wave-like properties. This idea was confirmed experimentally by the Davison-Germer experiment in 1927, which showed that electrons scattered off a crystal surface in a manner consistent with the wave properties predicted by de Broglie's theory. In the mid-1920s, a group of young physicists, including Werner Heisenberg, Erwin Schrödinger, and Paul Dirac, began developing a more formal theory of quantum mechanics. Heisenberg formulated the uncertainty principle, which states that it is impossible to determine the exact position and momentum of a particle at the same time. Schrödinger developed the wave equation, which describes how the wave function of a particle evolves over time. The wave function is a mathematical description of the probability of finding a particle at a particular location. Dirac developed theory of quantum electrodynamics, which describes the interactions between electrons and photons. In the decades that followed, quantum mechanics has been applied to a wide range of phenomena, including the behavior of atoms and molecules, the properties of materials, and the behavior of nuclear particles. It has also had a profound impact on our understanding of the fundamental nature of the universe, and has led to the development of technologies such as transistors, lasers, and magnetic resonance imaging, MRI. Today, quantum mechanics continues to be an active area of research, with scientists seeking to understand and harness the strange and counterintuitive phenomena that it describes.